In the following video, we're going to examine how we can apply systems of equations to story problems. So in this story problem, it says, suppose rent-a-truck's rates are $50 a day plus 50 cents per mile, and Sam's U-Drives are $70 a day plus 45 cents a mile. The first part is asking us to write two equations to model this information. So we need to represent, I would say, the two companies, the rent-a-truck and Sam's U-Drive, as our two equations. So in these equations, we're trying to figure out the total cost. So let's let X represent, if I look at my information, rates are $50 a day and 50 cents per mile. I'm going to let X represent the number of miles. And I'm going to let Y represent the cost for a day of rental. Cost for 1 day of rental. Now, it's always important to understand what your variables represent. X is number of miles and Y is my cost. So my cost is going to be my total for both equations. So I'm going to write my rent-a-truck equation in green. And so when I do that, I know it's going to be Y equals, because Y is my total. So the information I get has to add to Y or subtract to Y, depending on what the problem says. Well, if I look at what else is given to us with rent-a-truck, I'm told $50 a day. And I'm labeling it so that I'm trying to figure out the cost for 1 day of rental. So that means that $50 is going to occur only once. That is our constant. And remember, constant is a number with no variable attached to it. And so that plus 50 is just going to be a one-time fee for renting it 1 day. And then I see I have 50 cents per a mile. Well, that means that's my rate of change. That 50 cents is going to change with every mile. 50 cents for 1 mile, $1 for 2 miles, and so on and so on. So that rate will change with every mile. So then I'm going to have 0.50x. Now let's do the next equation. And I'm going to use blue for the next equation. So let me change the labels to black. And now I've got blue for my Sam's U-Drive. And so again, my total for Sam's U-Drive, $70 a day. Again, that's my constant. It's a one-time fee for renting for a day. So that will occur only once. And 45 cents per mile is my rate of change. And so I have 0.45x. And so there is my system of equations. Rent-a-trucks rates represented by the equation y equals 0.50x plus 50, and Sam's U-Drive represented by the equation y equals 0.45x plus 70. Now part B is asking us to find the mileage at which the cost for the two would be the same. And this is why it's important to understand what your variables represent. I want to find the mileage. And remember, that means we looked at X, we set X as our number of miles. So we want to find X. Well, to find X, I'm going to use my substitution method approach. This approach allows us to set the two equations equal to each other. This says y equals, and this says y equals. So I can replace the y here with 0.50x plus 50. So I have 0.50x plus 50 equals 0.45x plus 70. Now I'm going to get the variable over to the left side, so I'm going to subtract 0.45x from both sides. That is going to give me 0.05x plus 50 equals 70. move the constant to the other by subtracting, so 0.05x equals 20. And then I'm going to divide both sides by 0.05. And that is going to give me x equals 400. So x is the number of miles. So the number of miles at which the cost will be exactly the same is 400 miles. And now it's asking in part C, what is the cost when the mileage is the same? Well, we found out the mileage is the same at 400. We found out the cost is the same when the mileage is 400. So that was our x. So I know that x is 400. I want to figure out my cost. And we said the cost was our y. So we're going to try and find what is y when x equals 400. What is the cost when the mileage is 400? So it doesn't matter which equation I use here. I can use my Sam's U Drive, or I can use my rent-a-trucks. I am going to use the rent-a-trucks, that 0.50x. My y equals 0.50x plus 50. Well, I'm told x is 400. So then I have 0.50x, which is my 400, and plus 50. And that's going to be what my y is. And so then I do my order of operations and solve. Now, 0.5 is really 1/2, so 1/2 of 400 is 200. So I really have 200 plus 50, so my y is 250. So the total cost, my y, is $250. Under what conditions should you rent from Rent-A-Truck? So now we actually have to think about what this means. If we look at it, we're told the two equations are going to have the same cost at 400 miles, and that cost is 250. So let's bring up the two equations, the system of equations we created. Now this system of equations that we have says y equals 0.50x plus 50 is for Rent-A-Truck, and y equals 0.45x plus 70 is Sam's U Drive. So under what conditions should you rent from Rent-A-Truck? And so here we have to examine what this means. After 400 miles, what's going to happen? This is going to be 401, then 402, then 403, and 404. And so what happens with Rent-A-Truck is after you hit 400, this rate of change is going to increase faster than this rate of change. And so the best time to actually rent from Rent-A-Truck is when you're traveling less than 400 miles. Since both equations are the same at 400 miles for cost, after you hit that 400 miles mark and you travel further, what matters is what's your rate of change going to be? What's going to be your increase every mile from that point on? And so every mile from that point on, your Rent-A-Truck is going to increase 5 cents more for every mile from that point on. And so we have to make sure we understand what this rate of change means. So if you're driving less than 400 miles, you should rent from Rent-A-Truck. But if you're going to go a longer distance, like 700 miles, you're probably going to choose Sam's U Drive since the rate of change is smaller for that one. So this video, I hope you understand how we created the equations. Defining the variables is very important, understanding what they mean, because then when I'm asking for more information, what is the cost, the variable I'm looking for? What is the number of miles for which the two costs would be the same? I'm asking for mileage, that's my x. So make sure when you create a system, know what your variables represent, and also make sure you understand how they go about building the equation. What's your rate of change? Is there a constant? And you you can create the equation from that information.